Okay, so percent increase and percent decrease. I'm going to be a little bit over the top with this just because when it's easy, but when it's hard, isn't it? So if you just follow the recipe, you can do the hard ones easily if you just follow it, okay? So I'm going to show you the recipe, but it's going to be with all the easy ones also, if that makes sense, okay? So you have an initial amount A, okay? If you are increasing, do you remember what goes into these parentheses? So a percent increase, 1 plus the percent increase, okay? So really that would look like if I had a 55% increase, that would be 1 plus 0.55, because remember you have to change percents to decimals in order to add them because they need to be in the same type of number. So then that would be a 1.55 multiplier. That becomes your ratio, okay? They use this all the time in banking and in science, right? Okay, so initial amount A, and if it's decay, it's the same thing. It's 1 minus the percent decrease. This is where it gets a little bit confusing sometimes for kids. Like if you had a 15% decrease, that'd be 1 minus 0.15, so that'd be 0.85. So I always say, like, 1 is your baseline. 100% of your whatever, money, whatever. 100% is a 1. That's your baseline. If it's above that, you're increasing. If it's below that, you're decreasing. So like this first one, you can kind of already see, right, that this is a 20% increase. You always go to the one that's attached to the X, okay? So here's how they do it with like the recipe. So they'll say you set whatever that is equal to 1, and this is an increase. So I'm going to use this equation. And instead of a percent increase, because that's what I'm trying to find, I would put an X there. Are you with me so far? Yeah. So 1.2, I'm going to set it equal to 1 plus X. If I minus 1, 0.2 equals X, so that's a 20% increase. Which you could kind of tell from that because it was above 1, right? It was 20% above 1. Yeah. Okay. So this 0.7, same thing. I'm going to start with 0.7 and set, bless you. Since it's a decrease, I'm going to use this formula and I'm going to make it into an X. So like 1 minus X. So if I minus 1 from both sides, notice that if you have 0.7 minus 1, you end up with negative 0.3. And that equals a negative X. So then a positive X is just 0.3, which is a 30% decrease. The next one is a little bit trickier, okay, where you'd almost need to have a calculator. So if I set this up, I'd have 0.025 equals 1. This is a decrease minus X. So if I minus 1, 0.025 minus 1 is negative 0.975 equals negative X. So X equals 0.975, which is a 97.5% decrease. How are we feeling? Good? Easy peasy? Okay, so next, they just want you to go from, like, they talk about it and they want you to write out the equation, okay? So it says create a function. When I create a function, I'm not writing y equals for all of these because they all are story problems, okay? So we have to start, hopefully, getting into the habit of, like, the Holmes value would be V, and then T is my X per year. So like I would change it based on the year, okay? So that equals, I have my starting value, which is 200,000. And then it increases by 1.5%. So that's a 1 plus 0.015. So what's that? 1.015 to the t. Don't forget the t. It's not an x. I think the only time they really get picky about that is on the computer.
Why would it be 1.015?
Because it's 1.5%, not 15. So just be careful. I know, because our brains always go to 15, don't they? Mine does. Okay. Population what? P of fruit flies is currently at 150, but it's increasing by 205. So P of D, you start with P and D, okay? I am starting with 150 of these little annoying, gross things. Increasing by 205%. So 1 plus 2.05 is going to be 3.05 to the power of D. Any questions?
No, move on.
We're doing good?
Yeah.
Awesome. Okay, so the next two are decreasing. Okay, so Mr. Brust's yard is getting overrun with weeds. The first year he bought his home, there was 1,800 square feet of grass. It is decreasing per year. So G of T is 1,800 times, okay, decreasing by 28.1. So 1 minus 0.281. What's that? 0.719. 0.719 to the T. Try the last one. See if you can get it. Okay, so I got V of T equals 11,000 times 0.843 to the power of T. Good? Okay, so when we talked about like how this is represented, science comes about. When do you guys do half-lives? Is that chemistry? Physics?
Yeah.
Biology? I don't even know.
Look at apes.
Apes does it?
Uh-huh.
Okay. So you have an initial amount, A. Since it's being cut in half, that becomes your R. Okay? Since it's being cut in half, that becomes your R, which is 1/2. This is the part that gets kids, okay? It's the total time divided by the half-life. So for an example, if something was cut in half, like it had a half-life of 10 days, and you asked after 40 days, you would put the 40 on the top and you divide it by 10, so it's getting cut in half 4 times. Does that make sense? Why that's a fraction? Okay, so you are taking the half-life 4 times. It's going to take it, and then it's going to cut in half, and then it's going to cut in half, and then it's going to cut in half. So that's why there's 2 numbers, because you have the total amount of time and then the half-life time.
So the 10 goes to the H, 40 goes to
Yes, this is total. Like your total time. Yep. And then your H is your half-life. Does that make
the
sense?
What do you think is that?
Like everything's different. So like, I don't even know.
Maybe
Like
like bacteria kind of thing, or like I'm just like
chromium or like any of those. What has half-lives?
I don't even know what that is. I actually don't know what a half-life is. So it's like, I'm kidding.
Radioactive elements, drugs, and other substances have a half-life, which is the time it takes for the quantity or strength of something to decrease by half. Radioactive isotopes have a physical half-life, which describes the time for half of the sample to decay.
So like.
So if you dump oil out,
It has a half-life of 10 days. Like, what does that mean?
it's getting cut in half it's like,
4 or 10 days?
yeah, if
So
it's
what-
something that might be
what-
evaporating into the air.
That makes sense. What does the 40 days mean then?
That would be the total, like if somebody said how much will be left after 40 days. It's going to be cut in half
What is
4
the 10
times.
When does the 10 days thing?
That becomes the H.
So what is 10 days though?
It's every half-life. That's just an example.
Why is there 2 different numbers? Why is 40 days and 10 days?
So it's saying every 10 days the population gets cut in half. So
H is
Oh,
each
and
different,
it's like, oh, okay, that makes a lot of sense. Thank you. Thank you.
yeah, H is the amount of time that it's getting cut in half, and everything's different.
That makes sense.
You know,
I was
like-
very confused.
Carbon 14 or uranium 238 both have half-lives. I don't even know what those are, but do you guys know? Drugs like cocaine has a half-life of approximately 50 minutes, which means you take it and then 50 minutes later your body still has half of what you took in your body.
Yeah,
Oh,
that's what we
that
do.
makes
Age is
sense.
like bacteria or whatever, when it's exposed to something, how long it takes for like half of it to die.
Like if you have strep throat and then you take your medicine, it's a half-life. It'll kill half of it and then
I got that. So I was genuinely just wondering what the 10 and 40.
yeah. Initial amount A, so this is A, and this is doubling. So the 2.5, they're not going to tell you. They're going to say it, they're going to write it out. A half-life or doubling. Okay? Same thing, the total amount of time divided by how often it doubles. Okay? Okay, so there is 150 grams of a radioactive material. Its half-life is 4,400 years. So to write the function, okay, I'm going to have G of T. Now, I start with my initial value. So I have 150 grams of this, okay? And it's a half-life. So that's where the 1/2 comes in from, okay? And then the 440 is how long it's going to take. So the T is the total time divided by 440. So if they say, how much will be left in 10,000 years or 10,000, years, you'd put the 10,000 up top. And then you could figure out how much of that substance would be left after 10,000 years. Okay. Mr. Bean's parents currently have 95 descendants. The number of their descendants doubles every 15 years. Okay, so what do we have? D of T.
equals 95.
Perfect. 95 times 2.
To the T over 15.
Perfect. T over 15. Perfect. So that just like the T would be like, oh, in 30 years it's going to double twice, right? 30 divided by 15 would be 2. That's all that means. Okay. This part is a little bit confusing. I feel like when I read this, it gets confusing. Okay. So let's look at this number 10. If f of d equals 3 to the power of d, that indicates that a quantity increases by a factor of 3, right, every day. So when they put the 7s in there, what does that indicate, do you think?
5 days of the week.
Yes, okay. So you're going to have to look at what they're giving me. They're telling me every day. Okay, so you look at the unit and then you relate it to the number. Okay, so this is stating that it's increasing by 3 to the 7th because that is in the R ratio spot for this function. Okay, and then it's so then this would be 7 days, which is how much? 7 days equal 1 week. So then it's increasing by 3 to the 7th every week. So if you look at this one up here, okay? if they gave me every year in 52, what does that mean?
Weeks.
52 weeks, yep. So look at number 22. Number 22 in the homework, or the practice. It's the last one, huh?
They do it with 365.
That'd be days, yep.
Yeah, right.
Yep. Days per year. Okay, so what you do is 2 to the power of t indicates that the quantity increases by a factor of 2 every year. Then this one right here, okay, so you're going to look here, and this is 1 year, and this would be what? 100 years. So you take whatever they give you and you tack on the number. So this is going to be 100 years, which is actually what? 1 century. Perfect. So then that just means it increases by 2 to the 100th every century. Bless you. So look at the year, tack the number on, and then just figure out what that would be. Or look at like this one. This is seconds, and then it's a 60. So what's 60 seconds? Yep. That's how you figure it out. Easy peasy? Okay?